Let's get started. So, let's do a roadmap of the homework quick. We're pretty much done with homework 4 content, believe it or not. We're all the way up to objective 1. Okay, we're not almost done. We're all the way up to objective 1. After today's lecture, we're going to be all the way through objective 4. So after today's lecture, after really like the first 10 minutes of today's lecture, we're going to get you through objective 4. And then all of next week is going to be getting you ready for HTTPS. And getting you understanding the concept. I got to talk about encryption first before even starting to talk about HTTPS. Then we'll talk about how to set that up using Nginx as a reverse proxy, generating and installing certificates, what even is a certificate, and things like that. There's a lot that goes into HTTPS. And then for your homework, it's not too much work. It's some configuration, but very similar. I mentioned this in the last few lectures, but very similar to WebRTC, where I have a lot of lecture content to give you all the background about it. And then when it comes to your code, there's it's not negligible what you have to do, but it doesn't reflect 3 lectures worth of content, in my opinion anyway. So after today, objectives 1 through 4 are all on the table. But you're all thinking about homework 3 anyway, so hopefully not this time. Hopefully after homework 2, y'all learn to start earlier in this class, but it is what it is. Project checkpoints as well, just a last reminder tonight. Once the deadline passes, the TAs it's fair game. The TAs can look at your repos and review your project reports. There's no submission or anything for this. We have all of your repo links. If that's not true, send your repo links. I think I'm still missing a few for some of the randomly formed teams, so if you haven't emailed me yet, make sure you get your repo link to me so I know, so the TAs know where to look for your reports. Tone this down a little bit. So we know where to look for your reports. And honestly, we're probably not going to get to those till probably at least starting Monday night. We have Tuesday night, maybe? I don't know. We're probably not going to get to the reports right away. We have meetings Tuesday nights, me and the TAs, and that's where we'll talk about all our logistics moving forward. So don't treat this as a hard deadline. If that deadline passes and you don't have your reports, we're going to look into your repos, and the whole point of this checkpoint is to give you feedback on your reports. So it's not like a hard deadline, this midnight tonight deadline. That midnight tonight is just the first chance that the TAs have. Like, I'm not going to let them look at your reports, review your reports for the checkpoint before then. They have to at least poll after that. So keep that in mind. And as always, I recommend having at least 1 report done before the checkpoint. It's much more beneficial to have 1 report completely done than have all 3 reports kind of started. If you have 1 report completely done, the TAs can give you feedback and say, yeah, this is exactly what we're looking for. Do this on the other 2 when you're good. Or they can say, this isn't exactly what we mean by reports. You got to fix these things. You have to do this different. And then you know not to make those same mistakes on the other 2 reports. So that's what I recommend. You'll do what you do, but at least take advantage of this checkpoint at some level. You don't want to miss this checkpoint completely, not get a round of feedback. Submit your project at the end of the semester. Maybe all your features are great. You have a completely working project. And my feedback to you is, your reports are nothing like what we expected. Like, this isn't what you were supposed to do with reports. Sorry, 0. You don't want that happening to you. That's the whole point of this checkpoint. Make sure you get something in so you can get some feedback on whether or not you're doing reports the right way. I won't pull it up again because I'm terrified of opening Piazza during lecture. But we have the course eval incentives. I talked about it last time. I won't reiterate it again. And I asked some of you had suggestions. If you do have suggestions, post them as comments on there, and I'll consider them. I haven't made any decisions on any of them yet, but there were a lot of suggestions made in lecture that aren't on that Piazza post. If they're not on the Piazza post, I'm not going to consider them. I'll just assume you were joking or something, which I think some of the suggestions were just joking. But get on there, and if you really like one of the ideas, upvote it and stuff. let me know that there's support for that idea, and then it'll weigh into my consideration. Yeah, Nicholas, if you want to review reports early, you can. I'll let you, but you'll have to review them again starting midnight. And there's one, oh yeah. We have next week HTTPS, yay. Presentation, oh, I got to set up this form. Or did I already? Maybe I did set this up. No, I didn't. So I got to set that up, and then I'll be talking about that next week. No classes for Thanksgiving, for fall break. No class on Monday. I don't know why the university doesn't just cancel class the whole week, but I'm going to. And then when we come back, I have some nice demos. This is where I always like to start a project from scratch and show you the entire process of, not necessarily starting a project from scratch, but taking a project that we've seen in lecture and going through the process of deploying it to the world. This is a requirement for your project, so I want to show you that whole process of how you can use Docker Compose. I'll use DigitalOcean, which I recommend. You get it in your GitHub student pack. You get free DigitalOcean credits. And we can talk about how to deploy. I'll run through the entire process in lecture. I'll even use CertBot and get HTTPS, even though I forgot to make that a requirement for your project, unfortunately. But I do still recommend doing that for your project. It's not too hard. And I'll show you how to do it. And then presentations. So we'll start getting the presentation schedule. And there will be, for some reason I don't have it on the schedule, but the final exam time is reserved for more presentations. So that's where the rest of the presentations will be. And the reason I want to go through the schedule, the reason I'm saying this, is after we get back from break, these 6 lectures, no lecture questions. I'm not going to have any lecture questions after break. Next Friday will be the last lecture question of the semester. So however that factors into any decisions you're going to make, whatever you're going to do, you'll do. But I want to let you make informed decisions. With that, any questions about anything? Open it up to anything. I did that in 116 today too, but they only asked 116 related questions. Yes? I haven't. Did you make your suggestions on that Piazza post, and I'll review them? I checked after Wednesday's lecture, and there were only a couple comments. Even the suggestions that were made weren't even on there. So if you do want something, check that. If your suggestion's there, give it an upvote to get my attention a little more. I haven't made any decisions yet, though. There were only, I think, 2 suggestions. One of them was for a 4th objective. I already said I'm not doing that. I forget what the other ones were. But I'll do something. It was suggested last time, something with lecture questions. I'll do something with lecture questions if there's demand for that. I have no problem adding that to either the existing ones or adding a new tier. But I don't know entirely what y'all want. I know homework objectives are usually, that's where most of your grade's coming from, so I know you're going to want that. But lecture questions, I just don't know how much demand there will be, because my thought is usually students who are doing poorly, really poorly with lecture questions, probably aren't even going to be here to make suggestions. They're not going to go on Piazza and make suggestions, and they're probably not going to fill out their course evals either. Those students just don't do anything. So if there is demand from the students paying attention, then I'll add it on there. But I don't like having an incentive that just helps the people who aren't doing anything, not even filling out the course eval. Yeah. Yes, so you create a directory in the repo named reports, and then put your reports in there. The format of the reports can be whatever you want. You can have a link to a Google Doc, or you can convert it to a PDF, whatever you want. But we're going to go to the root directory of your repo, look for a directory named reports, and then whatever's in there we're going to look at. I'm here and doing poorly on lecture questions. So if that's the case, I haven't looked at all the stats, but if you're here and doing poorly, let me know. Maybe I'll add that incentive if there's support for that. Because if somebody's doing really poorly on lecture questions but also submitting them, I can't assume that you're here and doing poorly, because a lot of those people are people who don't show up and just take a random guess and take their 20% shot. So I don't really have a good way of knowing unless, I take attendance, and, it's tough. look up all the data, that'd be a big commitment. Okay, anything else? Let's talk about auth tokens and sessions. Not many slides today, and then I got some demos that I want to show. Some demos that may or may not go super smooth. We'll see how they end up going today. Sometimes they go smooth, sometimes they don't. So authentication tokens. Yeah, I think I mean, we won't be too strict. In the past, we haven't been strict on that, but it is in the requirements. That's a directory named reports. But yeah, open source reports, we'll find that. There are, so the tricky ones, please don't do this if you're one of these teams. Some teams will create a new branch called reports, and we have to scan all their branches for a branch where the reports are, and they're not merged into the main branch. That one is a little tougher to find. That one makes us do some work. Usually they get, their feedback is no reports found. They send me or the TAs an email and say, it's in this branch. Like, it delays things by a significant amount if you have it really hidden. We'll usually still do our best to find them, but if you just have them in a directory named reports, there's no question, we're going to find it. The one in chat, if it's named open source reports, we're going to find that pretty easily too. But if it's a subdirectory of source, I've seen that quite a few times. If it's another branch, like I mentioned, or the hardest one, to expand on that, the hardest one I've ever seen was on the main branch, there's a directory named reports that has a really, really weak report in it with barely anything in it. And also there's another branch that's not named reports, which does have good reports in it. And that's where they were working on their reports. That one, like, we're going to stop our search when we go to the main branch and find a directory named reports. We're stopping our search right there, and that's what we're grading. Especially when it's the project deadline and we're making grading decisions. We're going to grade the one that we find that's where we expect it to be, and then make a search for the one that has better reports. That's tough, and it's going to delay all your grading, and things are going to be a mess. Luckily, with GitHub, we can check timestamps of commits and things, so we can verify that you did have it in on time. Again, talking about the actual project deadline at the end of the semester. It's nothing's too critical for the checkpoint. I'm not going to care about timestamps for the checkpoint, but for the actual grading deadline, we can look at all the commits and see. This mic's too close to me, but yeah, if you put it, yeah, exactly. If you put it in a directory named "Do not open this," top secret, we will definitely find that one. We're always going to open that directory. All right, so authentication, 2 steps: registration and authentication. Registration, give me a username and password. Your job when you get that username and password is to take that password, generate a random salt, append the salt, hash the salted password, store that hash, and then also store the salt. That's your job for registration. For login, or for authentication, you get a username and a password. You take the password, you take the username, look up that username in your database, pull the salt and hash, which if you're using bcrypt is all one thing, one value, and then take the salt, append that to the password they gave, hash it. If the hashes match, you got yourself a match, and you say, yes, you're logged in. If those hashes are not identical, don't log them in. They're not authenticated as the person they claim to be, as the username they claim to be. So that's your goal for authentication for task 2. And we also want to generate a token for them. Because there's one big problem here, is with what I just explained on the previous slide, every single time a user wants to authenticate, they have to provide their username and password. So say they log in to your site to be able to get their main page, get their news feed, or whatever information you're going to show them. And then they want to make a post. They're like, oh, I'm going to reply to this thing on my feed. Are they going to have to type their username and password again? Because you're going to get another HTTP request saying, I want to post this reply on this message. Do they need to provide their username and password on that HTTP request? And hopefully the answer is no for every app you're ever going to build. Hopefully the answer is no, or else I'm not using your app if I have to punch in my username and password every single time. But that's all the functionality we have right now. As of Monday's lecture, that's the only way we've learned how to authenticate, and HTTP is stateless, so we can't just remember that information, can we? We can't do that. And the answer is going to be auth tokens. So we're going to randomly generate a token when the user authenticates. So they're going to give us username and password. We do all the database stuff. We handle salting and hashing and say, okay, you are who you claim to be. This is good. We're going to generate a random token and set that token as a cookie and send you that cookie as a set cookie header as your authentication token. So now whenever I get a request for this user again, well, let me not get ahead of my slides for once. This token, I don't have any strict requirements for the homework. Somebody asked me this in office hours yesterday. We don't have a strict requirement, but you should randomly be generating these tokens. The secrets library in Python is allowed. You can use that library. So use that to generate your tokens and just give that library a big number, generate big tokens, and you don't even have to think about it. But in practice, these tokens should have at least 80 bits of entropy. So however you're generating them, there should be at least 2 to the 80 possibilities for those tokens. If not, just increase the number. And there's no harm in going higher than 80 bits. If you want to go up to like 200 bits, more entropy is nice in these security aspects. And associate that token with the user. What I mean is store that in your database. So in your database, you should have like a user's database that should have username, salted and hashed password, which bcrypt just generates one value for you, so that only has to be one value in your database, and their authentication token. And you can, for your homework, you can assume that each user only has one authentication token. That's perfectly fine. In reality, using an app out there in the real world, I just don't feel like making you implement this. But in reality, you'd have multiple auth tokens associated with your account because you might be logged in on your laptop and your phone. You're going to have 2 different auth tokens for that. So you would have a list, some data structure of auth tokens associated with that user in your database. It's fine if you only have one, just have one value in your database for this homework. Then if you're using SQL especially, you don't have to worry about joins and multiple tables and stuff like that. I just don't want to force you through that. With MongoDB, it's not that big of a deal, but I don't want to put everyone using SQL at a disadvantage, which I don't think is many students, but still, I don't want to disadvantage them. Now, whenever you get a request, that user is going to send that token, that auth token, as a cookie. You take that auth token, you look up in your user's database, give me the user for this token, and you can authenticate in that way. Whatever that database returns says, oh, that token goes to this user. Okay. Then at some point in time, for this user, for somebody to send me a request with that token, with that auth token, then that user must have sometime in the past been authenticated by me, the server, because I'm the one generating those tokens and storing them in the database. So if they have that token, they must be that person. You treat them as that person without asking them for their username and password again, because they have that auth token, and that auth token has more than 80 bits of entropy, so it's not like somebody just randomly guessed an auth token. That ain't going to happen. I mean, it's one of them technically possible, but with high probability, they're not going to be able to generate a valid auth token for any user because 2 to the 80 is such a ridiculously huge number. And if you're not comfortable with that, just increase the entropy. Make it 2 to the 200. Nobody's going to randomly guess a token. It can't happen by accident. If it's a valid token that is in your database, you treat that user, that request, as it's coming from that user. as if they authenticated, because they must have authenticated in the past. And that's it. That's auth tokens. You generate a random token, you set it as a cookie, you see that token again, you treat them as that authenticated user. Now you don't have to ask for a username and password. If you have like a max age or an expires attribute, directive, I forget the name of what they're called, for cookies. But if you have that on your cookie that says this expires in 5 years, that user doesn't have to input their username and password for the next 5 years, as long as they're using that specific browser, that machine, or they just copy their auth token over to another machine. Could happen. But you only log in once. A lot of social media apps, a lot of apps in general, you log in one time, and you can forget your password. As long as you don't want to log in on another machine, you can forget your password. You're just always logged in, because they don't have those tokens expire very often, if ever. Some just don't have them expire in 5 decades from now. And that's why you don't have to keep punching in your username and password. There's some sites I'll use for years and years and years and not remember what my password is. I only type it one time. But we have one issue. These tokens are as sensitive as passwords. If somebody recovers a token, they can impersonate another person without even knowing their password. That's an issue. We have this database filled with these auth tokens. So if an attacker recovers this database, or if the sysadmin decides to poke around that database, they can authenticate as you. Good thing we have a way to solve that. We just hash these tokens. When you store them in the database, store hashes of the tokens only. And then when you get a request, you read the token, you hash the token, and then check if that hash exists in your database. And since these tokens have ridiculously high entropy, they have whatever entropy you want them to have, there's no way to crack those hashes. Again, not literally no way, but there's no way. There's no way somebody's going to crack that hash if you have a reasonable amount of entropy. It's not like storing hashes of weak passwords. These are extremely strong. You just store the hash to the point where you don't even need to salt these things. There's no reason to salt your hashes of your tokens. You can if you want. It's up to you. But you don't have to salt these because they're already so high in entropy and so resistant to any known attacks out there that we just don't have to worry about it. We've got to worry about that. But you do have to at least hash them, because if they're stored in plain text, somebody has that database, they're going to impersonate any user on your site. It's, I hope we all agree, not good. Yeah, make it 2 to the 2 million. If that's how many, maybe 20 million. I can't see how many zeros there are. No, it's not important. Objective 2 is kind of insane. Kind of, yeah. And it kind of follows the trend of this course, where Objective 2 is the big objective in most of the homeworks. Objective 2 is where you're parsing and sending WebSocket frames. That's the bulk of Homework 3. Objective 2 is where you're parsing multi-part form requests. That's the bulk of Homework 2. And then Homework 1 is a bit of an exception, because Homework 1 is, by now you probably agree, easy across the board. Homework 1 wasn't too challenging. That's just the intro to the course homework. And same here. Authentication and tokens. Objective 2 is the big objective of the homework. I'd say this Objective 2 is easier than the previous 2 Objective 2s, though. It's a lot of functionality, but when it comes to coding, it's not a tremendous amount of code, especially using bcrypt. Bcrypt does everything you need in terms of hashing and salting in a couple of lines. There's not much. It's learning how bcrypt works, which they're just first README. Their first tutorial is going to tell you everything you need to know. I think it's the README on their GitHub page. Just tells you everything you need to know about it. And then generating the tokens and storing them securely. So there's a lot going on, but none of it's overly complex, given that you can use libraries for the hashing. Objective 3 isn't too bad. Authenticated chat. You already have their username and token in that database. So when you get a chat message, you go to that database, look up the token, grab the username. That's the username for that chat. And you already have the rest of the functionality built assuming you got it built in homework 3. You have the rest of the functionality built already for handling chat in general. Some of you are choosing to go back to forms instead of WebSockets, which is fine. You have the choice of how to build that. So you can go back to homework 2 and the multi-part form parsing. If you got that working but couldn't get WebSockets working, you can just go back to the homework 2 code. If you got WebSockets working and not multi-part, you can use WebSockets. But hopefully you have at least one of those two, and then you're just adding the username lookup instead of using the randomly generated username that we did in homework 3. Yeah, bcrypt you have to install. Tyler and Cole got you covered there. And add it to your requirements.txt. Add to your requirements so it'll be installed in Docker as well. But just like your whatever database you're using, whatever client code you use to connect to that, you have to install. Same thing with bcrypt, you have to install that. So with tokens, you get a request, check the cookie, see if it has a token. If it doesn't have a token, this user is not logged in. If it has an invalid token, this user is not logged in. You're doing that with a database lookup. If that is a valid token, find their username. With a database lookup, give me all the entries or find one. Find one entry with this token as the token, and it should return an entry. Grab the username from that entry and assume that that is that user. Oh, I went through this backwards. And then when you have an app and you have like a lot of pages that require authentication, there's certain pages that you don't want users going to unless they're logged in. Make sure you're checking those pages, and if they're not logged in, if this token doesn't check out, do not render those pages. Usually you'll redirect to a login page, for example. But you have to do this for every page that needs authentication, because the user, even if some devs will say things like, well, I just won't give them links to those pages if they're not logged in. Well, they're just going to go to the URL and punch in the URL for that page. So no matter how they access that page, you have to make sure they're verified to be able to view that page. Make sure they're authenticated. Yeah.
So let's say you log into user A and B, and A and B are going to have different tokens, obviously, but like if you go back to user A, are you going to reuse the previous token that you generated, or you just create a brand new one and use that?
Yeah, so I forgot to add this to the homework. I was going to add a logout feature this semester. I forgot to. So if your login is user A and then login is user B, you would have to log out of user A first. Now, some apps now, like Google, is going to let you have multiple accounts and you can switch between them. But that would be extra functionality you would have to build on top of this idea. Generally, for the way I'm presenting it here, you would log out of account A. That would invalidate that token, and then you would re-log in as account B. Or if you're opening another browser, like you log in on user A on Chrome and user B on Firefox, then you can be logged in as both simultaneously, because those browsers are not going to share cookies between them. But if you open a new tab on the same browser, you're still going to be logged in as A until you log out and then log in as B. But you can't go back to A. I'll go one step further than this. But you can't go back to A depending on how the server is built. I'd say the way that most of you will build the homework, since I didn't require a log out function, you would log in, like you could just delete your token. That will log you out, like manually delete it. Log in as B, and then if you went to that token and put your token for A back in, your server would treat that as a request for user A, and you'd be effectively re-logged in as user A. Did somewhere in there I answer your question? You want to give me another shot? What did I miss?
Does that actually count as like a logout for login for user A?
It would depend on how you build it. So if you're logged in as A and then you send a new login request for B, what would happen?
Parameter at all, like a blank input for username and password.
It would depend on how you build it. It would depend on the server. So if you send in a blank, like no username, no password, but send a login request, well logged in as user A, yeah, it would be up to however you build the server. I don't know what functionality I would expect from that, like using an app. So you wouldn't give that option to your users, first of all, because once you log in, you can't get back to that form. So you'd have to be doing things that the devs don't want you to be doing, and then it's going to be up to them how they handle that request. If they just reject it, if they thought about this and said, if I see a token on a auth token on a login request, I'm just going to ignore it. That's probably what I would expect, just ignore the request. Or do they treat that as a brand new request and say, okay, you have an auth token, let's override that with a new one. It'd be up to the devs how you want to build that. Oh, I thought you were asking a more in-depth question. I should have known you were just asking about the homework. For the homework, we're not going to test that. Is the homework answer. We're not going to test that in 312. Cookies are these auth tokens are sensitive. Be careful out there. If somebody steals a token, and this comes to our directives that came to me, this is where our cookie directives come into play. HTTPS only, secure, same site, strict. All these things can help prevent those cookies from being hijacked. Because if somebody accesses that auth token, it's done. Like they hack that user without having to hack their password at all. All the hashing stuff, like they don't have to break hashing. They don't have to do brute force or rainbow tail. They don't have to do any of that if they get that token. And guess who has your tokens? Not too many people. It's not that scary. But anybody with physical access to your laptop. If somebody wants to, you walk away from the room and your laptop's open and somebody knows what they're doing, or you know what you're doing to someone else. I don't recommend that, but you go to their cookies, copy, paste into some chat that you're both in, and you can be them. Like anybody with physical access to your machine, we don't have any mechanism to protect you from that, because we're going to treat you as the actual user, which in most cases you are. So physical access to your devices is always going to be a security threat. So let's do a demo. This is the one that can go wrong, so let's see if I can do this time. I always pick on the same site, which is less exciting these days, but Congregate. I forget what change they made. They stopped supporting HTML5 or something. I forget. Or no, they stopped supporting... I forget. But everything has to be HTML5. It was kind of dead for a little bit. And I'm already logged in. Cool. I'm going to go to Chrome. And I'm not just going to go to Chrome. I'm going to go to an incognito window in Chrome. By the way, incognito does not make you anonymous online. It doesn't really protect your privacy really at all, in case you're wondering that. Incognito, the main use for incognito windows is to hide your browser history from other people who have access to your machine. So when you're in high school and sharing a machine with your parents and you don't want them knowing what you're doing, that's where an incognito window comes in. Now that you don't have to worry about hopefully you don't have to worry about your parents snooping on you, much less useful, but still useful in some cases. VPN is what you want to actually get privacy online. So I'm logged in here. I'm not logged in here. It's a incognito window on a different browser. It doesn't have any of my information, but we will see. Actually, I didn't check this before, but pretty much every app does this. If we go to application, we can view all of our cookies. So even though I'm in an incognito window, actually, let me start a new incognito window. just to show this off. Oops. I have to have a window open to open an incognito window, apparently. Then I'm going to open up the console. I'm going to go to Network, and I'm going to go to congregate.com. I got a redirect, which then redirected me. Fun. And then I finally got the website. And I shouldn't have any cookies. It's an incognito window. It shouldn't be sending any of my private information, especially including cookies. But on my first request, I can see my response, and hopefully I didn't check this, so hopefully set cookie, set cookie, set cookie, 3 of them. And then on subsequent requests, there's going to be more cookies, more and more cookies sent until I have all of these, oh, not too many. It's just the first one. Until I have all of these cookies set from a whole bunch of different interested parties. Oh, all congregate. Oh, actually all congregate there. But if you go to like Twitch, you're going to see a bunch of Amazon, and you'll see some Google, even maybe some Facebook. You'll see cookies from all kinds of interested parties that want to track everything you're doing online. Even in an incognito window, they're going to be tracking you through cookies. So this is, I didn't mention this, but this is another use of cookies, to use tracking cookies so they can send you targeted ads. Even if you're not logged in, they'll set cookies, third-party cookies, that'll be sent to every site you visit. You'll be sending these cookies to, reporting back to Google, hey, this dude's on Congregate now. Hey, this dude's watching this channel on Twitch. And then all that information gets amassed, and then you get targeted ads, even as you're browsing the internet. Even in an incognito window, if you're in that window for long enough, you're going to start getting targeted ads, depending on your browsing history. Anyway, if I go to where I am logged in, everything's so zoomed in, I can't see what's going on here. Application, yeah, here I got some Twitter. Twitter didn't send anything here, though. Strange. Try to resize these a little more. Come on. But I go to Congregate, and I'm going to have a whole bunch of cookies here, and I'm going to look for the directives, HTTP only. I got a couple that are HTTP only. Oh, these are session cookies, though, so these aren't going to be my auth tokens. I just want to see all the information. Here's my secure directive. Here's my same site directive. And I can see all the values for each of these cookies. So secure, this is a session token though, right? I don't want that one. But I'm going to grab some of these. Congregate session, no, that's obviously a session cookie. And I'm going to take the cookie. What is going on? Nothing wants to resize for me. Let's make this easy for me. And I don't have that cookie here. I'm going to take this session cookie, actually.
They went through some weird server-side thing where they only store session authentication, and then they authenticate the server, so I don't know.
Maybe. Congregate session. I don't know why this is taking me a while. But I want to paste this session. So now I'm going to switch my session over to the session that I have in the other browser. And I need to get... It's hard when I can't see the things. Ads, marketing, personalized ID. I think I want this one. Or maybe guest ID. No, I already did it. So Sorry, I missed the big moment. So all I did was copy that session cookie over. So yeah, they are doing something strange by having session tokens for that. But I just copied the token over to my incognito Chrome from my non-incognito Opera. I just copied that token, and Congregate said, "Oh, you're Hartloff JL. I know you. I gave you that token." And that's it. That's all we had to do. I didn't have to type in a password. I didn't have to hack anything. All I did was grab that token that the website's looking for, which can get tricky. As you saw, there's like 1,000 different tokens. I always forget which one is which, no matter how much I look at them. But I'm authenticated without having to type in my password. I just use that token, bam, authenticated. No passwords needed. And the last thing, I do have one more thing. So we talked about entropy last time and secure passwords, and I did a little bit of math on a calculator, but I want to do it a little bit differently here. If we have, I just want to run a couple of numbers for you just to visualize how entropy works. If I have 90 alphabet size, so this is our uppercase, lowercase numbers, special characters, and I have an 8-character password. That's going to give me a certain number of bits of entropy that we looked up last time, but I want to show how did I not see that code? But I'm going to show how long it would take to break a password given a certain number of attempts per second. So we're going to give an attacker, let's see, 1,000 million, billion, trillion, 100 trillion. Why not just make it a quadrillion? Actually, wait, not yet. Let's start with 1 million. So 1 million guesses per second, and you have your password that's uppercase, lowercase, special, because I had to scroll down, not up. Uppercase, lowercase, number, and special character, completely randomly generated 8 characters. We're going to get this many possible passwords. That's 51 bits of entropy and 143 years to crack that password, which is quite a bit if they only have 1 million guesses per attempt, or 1 million guesses per second. Now, say they have a strong GPU, maybe a server farm or something, and they get 1 billion guesses per second. That number's going to go way down, and, well, 0. 0 years to crack. I don't want to switch my code to number of days. Well, let's do it really quick. Let's get rid of the 365 just very quickly here. 52 days to crack that password. So a long time, but not tremendously so. Let's give them a little bit extra power, billion, trillion. Let's give them a quadrillion guesses per second, which of course is going to be 0 years. But let's increase our entropy. Let's say instead of 8 characters, we use 20 characters. We're using a password generating system, a password manager, and we have 20 characters for our password instead. It's going to take that many years to crack, even with a quadrillion guesses per second. It's going to take so long that the sun's probably going to burn out first before they're done cracking your one password that you randomly generated with that password generator. This power of exponentiation is really strong. This is 130 bits. And if we do change this and just show what 80 bits is with a quadrillion guesses per second, even 80 bits, our general standard, is going to take 38 years to crack, which is pretty good because usually you're not going to have a quadrillion guesses per second, and that's going to be 38,000 years if they have a trillion guesses per second. But these passwords aren't going to be broken, even at 80 bits. But if you don't like this, just crank it up higher. And have a great weekend. I'll see you all Monday. You can come down and ask if you want.